Hello and welcome guys. In the last video we discussed about visualization of single audio, and also we compared this blues visualization with the ZAP visualization. So right now I'm removing this part. First let's focus on blues audio. Okay, so I'm taking the visualization of this. Let's run this cell again. Okay, so this is the visualization, and this is how you can play any audio file, okay, using Y and sampling rate. As we discussed that we can't build a MEL spectrogram directly using it and feed to the neural network, so we are going to follow some other approach like making chunks of this audio and then seeing the result, and then we will see the difference between the chunks visualization and this entire audio visualization. Okay, so first let me show you the visualization of chunks, then we will decide that which audio we'll put, like whether we will take this entire 30-second audio and build a MEL spectrogram using it and feed to the neural network, or we will use the chunks of audio and build a MEL spectrogram and then we will feed that chunks MEL spectrogram to the neural network. So we have two approach. So let's do a visualization on chunks of audio, then we will come to some conclusion. Okay, let's give here markdown doing visualization on chunks of audio. So now let's give first the path of that audio. So I'm giving here audio path, audio underscore path is equal to the same path. Here I am focusing only on this file first for our experiment. So let me take this file. Okay, now we will load this file. So we'll use the same command this. Okay, so I am using the same command here. So what I will do, I will remove this thing from here. Why I am doing this? Because I will write here SR is equal to none. So what it means, SR is equal to none means that we want to keep original sampling rate. That's why I am doing SR is equal to none. I want that whatever sampling rate exists in this audio file, take that one. Okay, so to make a chunk of this, I am defining defining the duration of each chunk and also overlap. Okay, what is overlap? Like if I am taking 4 seconds, then I want 2 second overlap so that I can maintain the previous information also in my next chunk. Okay, that's why I am giving here chunk overlap and chunks. Okay, here chunk duration is equal to, I am giving here 4 seconds, and overlap I am giving here, overlap duration I am giving here, overlap duration I am giving 2 seconds. Okay, so what is this chunk overlap and overlap duration? Like here if I am selecting this 4 seconds, then I am taking first chunk as from here 0 to 4. Okay, and second chunk from 4 to 8, like that I am taking. But here I am also maintaining overlap of 2 seconds. So I am saying that take first chunk from 0 to 4 and second chunk from 2 to 6. Why? Because I want 2 second overlap also here. Okay, so that I can maintain the previous information in my next chunk, so that our model can understand, okay, so this is a continuation of this thing. This audio is coming in the next chunk. It doesn't become completely blank. Okay, that's why to maintain the previous information, I am maintaining 2 second overlap also. Okay, so we have defined our chunk duration and chunk overlap. Now we will convert this duration to sample. Okay, this is a duration like here. But as we know that when we have load our model, then we have seen that why it's almost 1.3 million. If I print here, like let's print for you y dot shape, if I am doing, and it's almost 1.3 million. Okay, samples are there. So I am sampling this whatever we have here, this duration I am sampling it, because we have to make this y also. Okay, so to create this y for this chunk, we have to do some mathematical calculation, because this y, this 1.3 million array what is here, it's of this 30-second audio. Now we have to make this y for 4 seconds. Okay, so to make that, we have to convert duration, that is 4 seconds, to sample. We have to do that. So what I will write here, I will write here chunk sample is equal to, I will do a multiplication of chunk duration with sampling rate. Okay, we'll do a multiplication of chunk duration with sampling rate. Whatever we got from here, okay, that is our sampling rate. We will multiply that with our chunk duration. Then we will get chunk sample. And same we will do for this also. Let me copy paste here. And this is our overlap duration. And this is our overlap sample. Overlap sample. Let's write here samples. So we will multiply that duration with sampling rate and we will get chunk sample and overlap samples. Okay. Now we have to calculate how many number of chunks exist in this 30-second audio. Okay. Like I already said that first chunk will be from 0 to 4 and second will be from 2 to 6. Third will be from 4 to 8 by maintaining 2-second overlap. So now we have to calculate how many number of chunks exist in this 30-second audio. Okay, to do that, let's give here comment, calculate the number of chunks. So I will give one variable num chunks is equal to, I will give here int, and in this I will pass np.ceil I will do, and on what np.ceil I will do, I will write length of y, whatever length of y is there, and I will minus it with chunk sample. Chunk sample, I will minus this thing. Okay, so length of y, which is 1.3 million, I will minus it with chunk sample. Okay, and then what I will do, I will divide this with chunk samples minus overlap samples, and I will do +1. This thing I will write here. So this np.ceil is going to be closed here, and this entire thing is closed here. So basically what we are doing, like if I slide this window, so first chunk is from 0 to 4 second and second one is from 2 to 6 second. So basically we are moving only 2 second from 0 to 4, then second one is from 2 to 6. So only 2 second we are moving forward. Okay, so that's why we are subtracting that chunk sample with overlap sample, because we are maintaining some overlap in it. So our moment is is the difference of this chunk sample minus an overlap sample. Whatever difference we got from here, that percent only we are moving forward. Okay, that's why we have subtracted that from here, and also we have minus that chunk sample from here, and then we have divided this entire thing with this. We are one less, so we have added one. Okay, so that's the calculation. So that's how we are doing here. So we have calculated the number of chunks here. Now what we will do, we will iterate over each chunks. Iterate over each chunks. So I'm writing here for I in range of num chunks, and now we will calculate the start and end indices of the chunk. Okay, let's write here, calculate start and end indices of the chunks. Start is equal to I will take, like from 0 I will start, so 0 into, I will minus that thing, chunk sample minus overlap sample. Overlap sample I will do minus, and then like 2 second moment is there. So here, like here we are dealing with array, so sampling rate also get multiplied here. So I'm taking sampling rate outside, and I'm understanding it with this in second. That's always saying that 2 second or 3 second, 4 second minus 2 second. I'm not considering the sampling rate because this chunk sample is product of this duration and sampling rate. Okay, but to understand this entire calculation and how this is happening, you have to go here and you have to understand from here. Okay, so this is 30-second, and we are forget about this sampling rate. Okay, for now. Okay, that is just to extract all the array values from this audio file. That's why we multiply that thing with sampling rate to take entire thing. Okay, so here first one will be 0. Okay, so if I show you that how it's happening, so first one will be 0 and second one will be start from chunk samples. Like I already said that first one will be 0 to 4, then second one will be from 2 to 6. Okay, that's why here I have written So at first iteration I will be 0. So 0 into something, start will be 0 and end will be start plus chunk sample. End will be 0 plus chunk sample, which is right now 4. Forget about this SR, focus here. Okay, so 0 plus 4, that is 0 to 4 in first iteration. And what happens in second iteration? I will be 1. So 1 multiplied by 4 minus 2, which is 2. So second iteration, it will be at 2 and it will be at 4 plus 2, which is 6. As I already said to you that 0 to 4 and second one will start from 2 to 6. Okay, so this is our start and end. Okay, and when we multiply this entire thing with sampling rate, then we will get this entire calculation, because here we are focusing on extracting this y. Okay, so once we multiply that duration with sampling rate, then we will get the index of that y. Okay, from where to where we have to take that array value. Okay, whatever array value we are getting here, if you are not understanding, then let me show you. Whatever array value we are getting here, it's based on the duration. It's of, okay, so to extract the index of, like here I said that 0 to 4, then 2 to 6. This is, I am talking in time form, in duration format, but now we are converting that duration to sample. So to talk in sample format, we have to multiply this with sampling rate. So that's why here we are not subtracting this chunk duration. Here we are subtracting this chunk sample. Okay. Okay. So we got this start and end index of this y, which we use to calculate our chunks. And now what we will do, we will write here extract the chunk audio. And now we will write here chunk, come inside the loop, and I will write this y. And then I will write here start and end. 0 to 4 I am taking. So I will write like this, and then what I will do, I will plot the graph of this by writing plt.figure. Fixed size I will give, 4, 2, and then I will write librosa.display dot wave show I will use, and inside this I will not give y, which I have given here. If you see this y in sampling rate, now I will give here chunk, and second one will be my sampling rate, which is SR. Okay, and then I will do plt.show. That's it. So what we have done, first we have taken this chunk duration 4 and overlap duration 2, and then we have calculated the we have multiplied it with sampling rates to calculate the chunk sample we have inside this 4 second, and what overlap we have in this 2 second, we have calculated that thing here. Okay, like here for this 30-second audio, we have this much of sample. Okay, this comes by multiplying this 30 with the sampling rate. If we multiply this 30-second with sampling rate, then we will get this value. Okay, whatever in number of second it is, if we multiply that with sampling rate, then we will get this value. Okay, so this many number of samples exist in this original audio. Okay, so now for this 4 second and for this 2 second, we calculated how many number of sample exist for in this 4 second and how many samples exist in this 2 second. We have calculated that. Okay, now next what we have done, we have calculated number of chunks exist in this entire audio. Okay, in this entire 30 second, if we are taking chunk duration as this and overlap as this, then how many number of chunks exist. This thing also we have calculated using this. Okay, because at last we want this new y. Okay, for this 4 second and 2 second overlap. So that's why we are dealing only in chunk sample and overlap sample. Okay, we are calculating this start and end index, and then we are extracting and we are taking only value from start to end. Okay, and then we are plotting the graph of it. Okay, now let's plot a graph. Let me run this cell. NP is not defined, it's saying. Okay, we have used here np.seal, but we have not defined here. So import here, import numpy as np. Run this, run all. My y. Now let's run this thing. See, my chunks are coming. This is for 0 to 4 second, and this is also 4 second, but it's starting in the original audio is coming from 2 to 6 second. Okay, so this is the entire audio visualization. Okay, if I count this thing, it's completed. Okay, if I count this 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Okay, total 15 it's coming for this 30-second audio. Total 15 chunks are coming because we are moving only 2 seconds forward. So if we move 2 seconds forward, then definitely we'll get 15 chunks. Okay, so this is what we are getting. And now let's see the difference between this entire audio visualization and chunk audio visualization. What do you think, which will be good to take forward and build ML spectrogram on the top of that and then feed to the neural network to train our model? It's not good. Why? It's very hard for the model to understand the pattern and extract the important feature out of it and train on that feature. If we build ML spectrogram on the top of this, then it's very hard for the model. Okay, and if we see this thing, then you will see that if we build ML spectrogram using this chunk, then our model will be able to understand the pattern from it. Okay, if we take some other audio, like here, if you see, this is some type of pattern exists in this audio. Okay, so that's why we will not use this direct audio file, but what I will do, I will show you the ML spectrogram for this audio file also, and also I will show you the ML spectrogram of whatever we are getting from this chunk. Of this 15 chunks ML spectrogram I will also show you, and this one ML spectrogram for this entire file I will also show you. Okay, then you will understand that okay, this is better than this previous one. And second point which is very important here is that if you use this big 30-second audio file and you will build a ML spectrogram on the top of it, then you will get only one ML spectrogram for it, for this audio file, for blues audio file. Okay, so you will feed only one training example for this audio file. Okay, for this one audio file. So for that entire 100 files, you will feed 100 ML spectrogram. Okay, but if you use this chunks ML spectrogram, then for each chunk we will get separate ML spectrogram. So total we will get 15 ML spectrogram for this one file. Okay, so for 100 file we will get 1500 ML spectrogram. Okay, so you can understand that we are not only getting good result, like here we are if we chunk it, then we will focus on that specific 4-second audio, and it's easy for our model to extract the feature from it as compared to this 30-second audio. And second thing is that if we use this 4-second audio, then we are also increasing the training example from 1 to 15 times. We are increasing the training example size. So we are going to feed more training example to our model. So it's very like our model will be able to learn and understand in more better way as compared to this one. Okay, that's why this chunking and this chunking is very important, and this overlap we are writing here so that our model can understand that okay, so this is 4-second audio, and then in next chunk when new chunk come and in that it start from 2 to 6 seconds, then that model will understand okay, so this 2 second is from previous one, in previous last 2 second is also matching with this first 2 second. Okay, so this is a continuation coming from the previous chunk to this chunk. Okay, so that's why we are giving here overlap of this thing, and this entire calculation we have done and this visualization we have done to see the difference between this big audio file visualization and what is the visualization of each chunks, how chunks is better than the entire audio file. Okay, so that's how we can see the difference. And here also, like while training, our model will get only 4-second feature, like first like only 4-second clipped 4-second feature our model will get, and we will plot ML spectrogram of only that 4-second feature, so our model will capture more detail using that. Okay, that's why it's far better than this 30-second audio. So we will go with this chunk approach. We'll do the chunk of each audio file, and then we will make ML spectrogram from it. So for each audio file we'll get 15 chunks, 15 ML spectrogram. So for 100 audio file we'll get 1500 millispectrogram. We have 10 class. If we are considering that, okay, in each class there is 100 file. So for 10,000 file, we will get 10,000 multiplied by 15. So we will get 150,000 training example. Okay. So if we feed that 150 training example to the neural network, then as compared to 10,000, if we give 150,000, then our model will understand it better and definitely we will get a good result. Okay. So that's why this chunking is very important. I think we have discussed a lot in this video. So hope you understand that what is the difference and why we are using chunks of audio. Okay. So point number 1, to increase our training examples, and point number 2 is to make our model to understand it, the audio file in better way. Like if we give 4-second audio, then our model will focus only on that 4 second and try to get insight from that 4 second, which he will use to understand the pattern exist in that training example, and same it will take from other training example, like from other chunks. That's why it's very important. Now in next video, what we will do, in next video we will use these chunks whatever we got from here, and we will make a millispectrogram for this audio, for this big 30-second audio file. We will make millispectrogram for this also, and also we will make a separate millispectrogram for this 15 chunks, and then also we will see the difference between the millispectrogram what we got from there. That thing we will see in the next video. So that's all for this video. We will meet in next video. Thank you guys. Thanks a lot for watching this video.